So let's take a look at how to determine some volume and some surface area of some different shapes. Before we've been working with perimeter and area, and these involve two-dimensional shapes. So these involve flat shapes like a square drawn on a sheet of paper or a circle. What we're going to look at now is we're going to look at things like volume and surface area, which involve more three-dimensional shape. This is my coffee mug. So this is a cylinder with a circular base. And volume, okay, we're going to take a look at how much it can hold. And surface area is how much material it would take to actually cover a shape. So we involve a lot of 3D figures, and we call those prisms. Okay? So we could have a rectangular prism, we could have a circular prism. Okay? Capacity is a measure of how much liquid a container can hold. Okay? So if a container can hold more liquid, okay, it has a higher capacity. We use those words sort of interchangeably. So you guys are really good at unit conversions by now, hopefully. So I'm not going to go through these in much detail. Okay. Once again, in Canada, we tend to use the metric system. These are using things like milliliters and liters, whereas the imperial units are more of ounces, pints, quarts. Okay. So if you do these conversions yourself, I think 8 gallons, you should end up getting 36.4 liters. And 163 milliliters ends up being 5.74 ounces. Okay. And you notice here some of these are written out in words and some of them have short forms, so that's how you would actually write it out as a final answer. And of course, the full solutions to these are on the summary sheets. So let's take a look at some prisms, which remember are just three-dimensional shapes. Okay. So prisms are three-dimensional objects that have equal and parallel ends. Okay. So we have bases. So on this one, you can tell, okay, we've got 4 by 6 by 10. This is a rectangular prism. Okay. This is a rectangular prism. And the reason I know that is because the base of this, you could look here or here, the base is a rectangle. This is a triangular prism. I know this because the base is a triangle. And usually we call a circular prism, it's called a cylinder. And the base is a circle. So those are some of the most common. Those are the ones we're mainly going to be working with in this unit. Okay. So volume can be thought of as how much space a three-dimensional object occupies. So remember, capacity is how much liquid it can hold. Volume is how much space it has. Very similar. Okay. Volume is always measured in cubic units. So remember, when we calculate area, it's length times width, or it's two different measures multiplied together, so there's 2 of them. Volume, because we're now in three-dimensional shape, we have 3 of them. So it's always going to end up being cubic. Okay. In general, so if you don't have one of these shapes, okay, the volume of a prism is always the base area. So remember, we looked at some of these bases. This one's a rectangle, triangle. Take the area of the base and multiply it by the height. So if we have this object here, it's got some width, it's got a length, and it'll have some, this is the new one, it's got a height. So volume of this is equal to the area of the base, which is, we already know, length times width. So length times width, and then we multiply that by the height. Pretty straightforward. It's 3 things multiplied together. This length by this length by this length. For a triangular prism, remember the area of a base of a triangle. Okay. Usually we call this the height, but to avoid confusion, okay, we're going to call that A, call this length C, call that H. So area of the base is equal to half. Usually that's base height, but we don't want to confuse it with this height. Okay. So that's the area of the base multiplied by the height. So the volume of this would equal half C times to put A first. C times A times H. Done. And for the last one, the area for the face of a circle, okay, is pi r squared. So the volume would be pi r squared, area of this, multiplied by height. This is the radius, and that's the height. Awesome. So that's how you would use your formula, your general formula for all different kinds of shape. If you had a funnier looking shape, hopefully if you can find the area of the base and you have a height, you can determine the volume of it.